Let us look at another problem in Routh-Hurwitz criteria. The problem statement is like this. Consider the block diagram of a closed loop control system. Find the values of K and A such that the system will oscillate with a frequency of omega is equal to 2 radian per second. And the system is given like this, the block diagram. So I have g of s, that is k into s plus 1 divided by s cube plus a square plus 2s plus 1. This is the g of s, and I have unity feedback and with the negative. Now this is input r of s, the output is c of s. So this is the closed loop block diagram. In that I have open loop transfer function g h of s. G is k into s plus 1 divided by s cube plus a square plus 2s plus 1, and h is equal to 1. So we need to find k value as well as a value. Two variables are there, two parameters are there, and such that the system will give you continuous oscillations, and those continuous oscillations should have the frequency 2 radian per second. That means it is kind of a design problem. In your system you have two parameters can be varied, and the desired is yes, I should have continuous oscillations, but those continuous oscillation frequency is 2 radian per second. So my system needs that kind of situation. Then we need to design what is the k value, a value. So using RH criteria we can easily find out k and a. Let us see how to find. Now the block diagram is clear. The g of s is available, h of s is available. So I will simply find the characteristic equation. So once the characteristic equation is found, then you can form the Routh's array. To get the sustained oscillations, we know that in Routh's array, one row must contain all 0 elements, and there should not be any sign changes in the first column. Because even if you have one row with all 0 elements, if you have one sign change or two sign changes are there, system will be unstable. When system is unstable, we cannot have continuous oscillations. For unstable system, the oscillations continuously increases. Okay, the first condition is there should not be any sign changes, and second is there must be one row which contains all 0 elements. Then we can say the system will be marginally stable. Then we can find out the corresponding variables k and a. Now the characteristic equation 1 plus g is equal to 0. Then when you solve it, when you simplify it, and you will be getting it as s cube plus a square plus s into k plus 2 plus k plus 1 is equal to 0. So if this equation is a third order equation, and for this third order equation there are two variables k and a. So with this variable k and a, then I will form my Routh array. So Routh array is s cube, this is rows s cube, s square, s power 1, s power 0, and we need to fill first two elements from the characteristic equation. So as usual, so what will be those elements? Now I have first element is 1, and the second element is a, k plus 2 and k plus 1. Then we know how to calculate the element for row s power 1. So that we can directly take it as k plus 2 minus I have k plus 1 into 1 divided by a. And s power 0 row you need not calculate, I can take directly k plus 1 to here. Now this is a complete Routh's array. Because we have s cube, we can easily write there are 1 or 2 calculations, that's it. Now what we need to do next? So we can look at the first column. As I said, the first condition is you should have all positive. There should not be any sign changes. So for that your k value and a value should be always positive values, right? We should choose the k value, a value always positive. So we can have negative values of any parameter in control system. So because control system is a physically realizable system, if you have negative values which cannot be realizable physically. Now the second case is I need to have one row with all 0 elements. Let us see conditions. The first condition I am going to take the s power 0 row, that is k plus 1. So when k plus 1 is equal to 0, your k is going to be minus 1 and k should not be negative. Therefore, this condition we cannot take. Take the next one. What will be that? K plus 2 minus k plus 1 by a should be equal to 0. Then you can write equation for a. A is equal to k plus 2 by k plus 1. Let this is equation number 1. That means I want to make one row 0, that row is s power 1. From that I am getting one relation between a and k. So if you have only one variable, I can find out what will be the value of k, but I have a also, therefore we will have a is equal to k plus 2 by k plus 1, that is equation number 1. Next, I want to look at what is the location of imaginary axis poles, because the sustained oscillation frequency is given. So how to get the location of imaginary axis poles? Take the auxiliary equation and you solve the auxiliary equation. So what is the auxiliary equation? Generally, auxiliary equation is formed with the quotient of the row just above the row which contains all zeros. Now in this particular rows array, s power 1 row will have all 0 elements. The next row element we should take it. Therefore, we can write a of s as a of s is equal to a square plus k plus 1 is equal to 0. Then I can write it as s square is equal to minus k plus 1 by a. We know that s is equal to j omega. Let us substitute s is equal to j omega here. So j omega square is equal to minus k plus 1 by a. So we know that j omega whole square, j square is minus 1. Therefore, minus omega square is equal to minus s plus 1 by a. We can cancel minus k plus 1 by a. So we can cancel negative sign here. Therefore, omega square is equal to, I have k plus 1 by a. But the omega value is given to you. What is the given omega value? Given omega value is 2 radian per second. Then if you substitute the 2 value here, so 4 is equal to k plus 1 by a. You can write a is equal to k plus 1 by 4. This is equation number 2. When you look at the equation 1, a is equal to k plus 2 by k plus 1. Equation 2 is your k plus equation 1 is k plus 1 by k plus 2 and equation 2 is k plus 1 by 4. Then when you equate these two, then we will be getting it as k plus 1 by k plus 2 is equal to k plus 1 by 4. You can cancel numerators, denominator, if you find it, you can find the k value as 2. So if you fix the k value 2, then you will be getting the condition. Another parameter also we need to calculate. Substitute k value in equation 2. So you will be getting a as 0.75. So in this problem, there are two parameters to be obtained, that is k and a. Those values are 2 and 0.75. If you fix those two values, then the system will have continuous oscillations with a frequency of 2 radian per second.